Okay, good afternoon. So, just I am going to start as I said earlier. I will now give introduction about the need of the GISTM. Then we will come for a panel discussion on the topic. Because as we know, the GISTM came in 2020. So this is the background. If you look at the type of tailings which is coming out in the world map, it will see South America, North America, African, Australia, all around, then India, China, Russia, and so on. So with this, that means so much of global tailings which is coming out, 46% is copper, 21% is gold, because the tailing is more than the resource. And this way, if you will see, this annual tailing is 12.3 cubic meter. That means that much amount of tailing is coming annually. And now if you will see, the total weight, if you take in a volume, 217.3 cubic meter of global tailings are accumulated. So for that, if I look at the database, there are altogether 1700 dams all around the world which is storing this mine waste as per the report by Church of England. Because Church of England, since yesterday Dr. Partha was talking about, many of might are about, but they are, that is the organization which is looking after, I mean outside India, that is the organization looking after this. So they, as per their database, there are 1700 dams. Looking at the history, first it was built in 1870, Japan and France. And in United States it started in 1881 in Arizona. And nowadays what is happening, in past 10 years, because this is the base of 20, because why this 2020, there was a need of GISTM. So 320 dams came in one decade. Whereas from 1940 to 60, it is average 43 dams were coming per decade. So now this tailing dam also, the amount of tailing generating are also making the requirement of so much of tailing dams to be constructed. So that was the concern. So this is like Brumadinho, Dr. Panda was talking about. Similarly, there was another was Valley. So that time only the investors wanted to know that the information from the mining organizations. And because the investors want, and you see the investment is not a small amount, so then mining department has, mining organizations or owners, they send some information about their tailing dams. And initial study shows that 166 dams already had issues in the past, and many of them also, they didn't provide the information about the mines. Whatever it is, see, previously I have said, not all mines, this is as per the record of Church of England, 1700. So then it said, again asked all that, all around the world, they said to the mining owners that you save this data regularly. Like yesterday we were talking about, like Vedanta from India is enlisted there. So then Reuters has taken this lead to a survey, because Church of England to 726 mining companies, half of them didn't respond. 1700, 726, then 356 or 66. So that means, why they didn't show? That means those are the dams may be under risk. So 1/3 of the dam are under risk. So for that, what we have to do? So that was the idea. So this first it was there in that tailing dams are different from many other classes of aging industrial assets and is a lifelong liability to the owner. Because you know the assets theory, suppose something is there, you can dispose of the asset, right of the asset. So they first define it as a liability to the owners throughout. Tailing dam may have potential risk to society, environment with obvious far-reaching consequence associated with its failure. So that is risk to society and environment. Then operational sustainability. For tailing dam owners, managing aging assets is the day-to-day reality of operational sustainability and future business strategies. And obviously then said they have to meet these regulatory guidelines. So minority owners, operators of the tailing dam needs to comply with government regulatory and guidelines for focusing on dam safety and effective risk mitigation. So this is what they said. Then if it is so required, then we need a guideline. So far yesterday I was talking about the Indian rules that I am skipping. So this is how this GISTM came into picture. So there GISTM has got different 15 principles, they have get it. But the basic important point was that to achieve zero harm to the people, the environment with zero tolerance to the human fatality. That is the basic need, the principle of this on which this GISTM is developed. So before going to the detail of this GISTM, so like these are the different documents which were or are available, but they have got, like now this yesterday also we are talking about this 2025, this ICMM has again come back. So if you go for this way, so they have got different outlines. So I will stop it here and go for the further principle, 15 principle. Before that I want to go with this panel discussion and then we will detail in because so far what we have done we will discuss and also in future. Because first we need to, just I gave a preamble, what is the GISTM, how it started. That means just you see this one organization, Church of England, has taken this initiative on behalf of the investors, because they are it is the major investor, but with along with the other investors, they have taken it. Because actually we didn't want to, so Dr. Pranam had said, so when there is a failure of one dam, Ajka dam failure in 2010 or the Red Mud, still they are able to pay the compensation. That company general gets closed. Bale has happened like this. So the company gets closed. Think about that time what happened to the investor. So that was the concern of the investor, that if you are not having a standard, a single dam collapse is taking, so many investors are losing their money because the company is getting closed. So for that reason, this GISTM has come into effect. So now I will request Dr. Panda, then Dr. Akhila, then Subhranshu, and Dr. Jagdish. Please come and so I will, let me start with Dr. Panda. So like I am starting with the basic foundation. What are the most critical element of GISTM that operators often overlook or misunderstand? That is foundation of tailing. So let's start with foundation of tailing. Yes. So starts with foundation of tailings.
So in the foundation of tailings or any foundation, we see the problem lies when there are clay soils. again, we also discussed like why clay soils are the problem. Because normally what happened, these soils, if there is any water, then that cannot be drained out under the loading, because when we put some load, definitely if it's if the water is drained out, then that's very good. But what happens in this low permeability soil, water cannot be drained out. So what's happening, like I was telling you, when you have any weak layer and strong layer combined, and if you load it, like apply the force on it, you will see the stress concentration mostly around the weak layer. So same thing happened here. We have pore spaces. There is soil. Within the pore there is water. So under the loading, if water is not removed, because if water is removed, then what happens? The soil subsides. The settlement happens. So that's good. That's what initially when we started doing the upstream dam, that was the main concept. Like we thought with time they will settle and problem will be solved. But when the water stay there, water cannot go, so what will happen? Water will take the load. And that will make your pore pressure will rise. And if you go back to the total stress conditions, so that will reduce your effective stress, and consequently your strength, which is a function of the stress, will also be reduced. And same thing happens in the tailings. Like yesterday in one of the example I showed that because of the foundation, which has a clay foundation, and also we observe the pre-construction water table and post-construction water table, we saw is a rising pore pressure. So that's why, like, if you look at that, we found, like, if you do the like downstream or the central line method is not that suitable, because same thing will happen under downstream or central line. You are again putting more load to the foundation, while the good part of the upstream is most of the load is going to the tailings.
Okay. Dr. Misra?
Any other?
I will perhaps support what Dr. Ponda said, and I'll add one part there, that yes, this is also what I was talking about yesterday, that it's a silt. Like most of the time when you talk about tailings, where they originate from mine rock, so rock lava or silt, they're fine grained, similar to clay, but very low plasticity, or lack thereof. And then now geotechnical textbooks as well, BA class or anyone you take, sometimes we say when we are allowing long term, or we allow long term, when we do a long term analysis, pore pressure would have been dissipated, and hence the undrained conditions. The drain condition would prevail. But if you look at your TSFs, most of the TSFs they fail after a while, or some period of construction, which can be technically considered as long term, but they fail in undrained scenario. So I think that's where somewhere we have to also, when we teach undergraduate students or master students about drained analysis, undrained analysis. Drained analysis is not equivalent to your long-term analysis, and undrained analysis does not necessarily mean it's a short-term analysis. So those two distinctions need to be made. And for our infrastructure geotech projects, they are fine, but in case of tailings, as Dr. Ponda was mentioning, the biggest enemy that we have is water. If you perhaps there might be some slides or some scenario where they will talk about if we have dry tailings, and we have seen it at one of the facilities in India for which we designed. I think they're the only or the largest dry stack producer. They have a dewatering plant. Dr. South Trust are there. We designed the facility. But it's very capital intensive, so we have to put a lot amount capex. Operationally, it might become easier for you to manage when you don't have water, geotechnically stable. So there is a continuum. You can choose really dry stack tailings, but that will, your design should be stable, water management will be much simpler, but you have to incur a huge amount of initial cost. But on the other hand, have whatever disposal.
Okay, Dr. Misra, I will come to dry stacking again. Dry stacking again, I will come again. So, because I will very specific on dry stacking because this is an alternate.
Water. So, yeah, so I agree. It's a poor water. It's a poor water. You just have to allow enough amount of time to dissipate and some trigger, just like when you have a static liquefaction or seismic liquefaction, they have to be managed. So, yeah, I'm aligned in the sense that it's the water that's the biggest enemy when we talk about tailings management. One of the biggest enemies at least.
Thank you. Dr. Sahu,
Yeah,
so you have covered Indian context.
Yeah.
Okay.
From Indian context, if you see, so in addition to whatever Dr. Ponda and Dr. Misra told, so we may check because these are fine particles, okay, so we can have some consolidation to know what is the rate of settlement. Clear? So what will the degree of consolidation? That criteria may be considered in long term. Okay, because in short term we are using this on drain condition, but in long term to add that whether it will be safe or not from if we are considering drain parameters. In addition to that, we can go for also consolidation parameters.
Okay, Subran, sir.
I'll give some insight about the site selection. Whenever we are choosing a site in the industry perspective, we don't have any data from before the site selection. And in case of feasibility, pre-feasibility study, there is no data available. So the identifying this problematic foundation, where that will create problem in a longer run, that I would request the industry and the owner to give the contingency fund on that investigation time where there is an investigation prior to the designing. Otherwise, at a later date when site is given to for a detailed engineering and we don't have any data to prove how the foundation is behaved, that is a very big problem, and to resolve that issue we need additional testing, additional support, and the design time, construction time, all impacted on that. So I would request all the industry person here, and as a consultant we also feel that when we arrive at a site, the client is giving the site, they are giving the site to only, but there is no inputs on the site. So treating a foundation, and another perspective is selecting a good geotechnical consultant for the testing. What we feel, we are assuming something based on some input, but we are not getting the real data. Real data, if we come to us, then suppose there is some issues in the data, there is no answer for the data. Suppose I am requesting the agency to give some information, they are not able to give the answers. So at that time we are feeling like we are bound in Indian context, we are assuming, and based on the assumption we are proceeding, and at the end we are arriving with a costly solution or having a difficult time to design it. So that is my feedback on the industry perspective on this difficult foundation materials.
Thank you, Dr. Akhila. As a consultant perspective.
Yeah, so actually from what I have heard and seen, I just feel that like some of the issues have come because of the presence of some layers, weak layers that are underlying, and it gets unnoticed or unattended to, and that can eventually lead to a lot of catastrophe. So as Subhanshu sir has mentioned, it's very important to have an initial proper exploration of that space in a geotechnical perspective, and to really be able to properly give a map of the borehole and cover the whole area appropriately and get sufficient samples and do the testing. As he rightly mentioned, it's very important to have proper testing, and also I believe it would be good if from the operator side somebody would have some idea about the data that is coming from the testing houses also. So that it's not just a consultant's job to just take the data from the testing and apply it and design the thing. There should be continuous interaction between the operators and the designer people to analyze the data from the testing that we are getting, whether it is possible, is it correct or not, whether we can trust it or not. So that quality of data is also very important. You are also paying a lot of money to get that data, and if that data is not good enough and any design being made with that is not going to work out at the end of the day, who will you hold responsible then? So that is an important thing that needs to be kept in mind.
Thank you. So now, because Dr. Misra has raised this about dry stacking, I will say it is a better option or just another trend. Dr. Panda, you can
start.
So,
Okay. Yeah, for me, like very few projects I have worked on the dry stacking, and we are still investigating. I am contacting a lot of people like the filtration. Right now, a lot of research is going on in filtration to reduce like the dewater rate. How much we can dewater? Because in one project I was working, we found that even with 15% moisture, that can cause issue. One thing, a lot of people in the dry stack normally miss, because we don't see, like, we know the settlement occurs. Even in the slurry we see the settlement, but the slurry settlement takes much longer time. But in the dry stack, that settlement may happen sooner than the slurry settlement. That part also we have to remember. And in the design, definitely we should consider the settlement. Because of settlement, what will happen? The water will come out. Because of the settlement, water will come out. And we have to see that where that water is going. In Africa, I think I looked into 2 or 3 projects where it's a dry stack projects, but it failed. And during the in the time of failure, there again the cause is the same thing, the water. So that 15% water, like we think that, oh, that's normal. 15% moisture is there, but the way you are stacking it, and see, like some of the stack can go up to 800 feet high. How much load it will generate? How much settlement it will make? The water, then a lot of water can come out. If all the water, that 15% water, and if you calculate the volume, it's a lot of water. We are calculating a base flow. Initial assumption, the consultant who did that, they didn't consider the settlement. So they thought that the base flow will be 10 GPM, gallon per minute. But then somebody else also calculated it. They came up with 800 GPM. So from 10 GPM, it went to 800 GPM. Then we also look over that, and we found something suitable. Like this is a client confidential, so I cannot release the number. But again, there we investigated a lot of things, like how to come up with the how much base flow will occur, or how we will design this settlement. You have to again simulate the settlement, and during the model, in your model, you will have to look into that. So settlement is the issue, but again, at the end, like we gave the client a design. But what I recommended, I want a pilot test. So that whatever properties we are assuming, they are mostly coming from the lab, but not necessarily in the field we will see that. So we recommended that let us have a pilot project. We will again test it, we will put instrumentation, and we will monitor it, and that will give us some idea so that we can design it for the future. So I can say that people are doing it, but still it is under research and a lot of people are working on it. But this will be the future, definitely. The slurry will be obsolete because slurry has a lot of waters and it is causing a lot of problem. And when we see this failure and how much money it costs when it fails, like I was mentioning, in 2015 failure they find $30 billion. So if you consider that, right now the filtration is very expensive, but when we consider that and again with the technology developed, dry stack is the future, I can say.
Thank you. Dr. Misra?
Certainly, I don't think that it is a trend or it's definitely not a catchphrase. It's definitely the future, but there are few factors that would govern. I'm not going to be exhaustive about all the factors. It would depend upon, it's an expensive affair. So for example, you have a mining lease as an operator and you have limited amount of space, but you have money, your revenue generated is really well, and then in that case, dry stack is something that you can really consider. If you can put some amount of money, dry stack, the same amount of solid and same amount of solid with water, you basically have more storage of tailing solids in the same amount of the same volume in a dry stack compared to a case where you have slurry sort of a condition for tailing. So it promotes storing higher volume of material in lower space, and that means that your densification or the density that you reach is often high. So that's a good management principle, but as as Dr. Ponda was mentioning, these are two extremes. One is the slurry and one is the dry stack. What is a global good practice, as I would say, is promoting unsaturated conditions in tailing. That's what we should be targeting. And what is unsaturated condition? Even if you can reduce, let's say you are depositing your slurry at 40% or 50% water content, if you can reduce it to not completely dry stack, let's say 30% or 20%, the amount, the volume that you save, that's going to give you more space to store. That may mean that water that you recover, you can reprocess it, use it in the mining town, that is reliant on it, so there is some saving in terms of water as well. And when you have cases, I've also seen dry stack designs can go wrong, and this ties back to the challenge of not identifying the ground condition properly. Let's say you're designing a dry stack, you said, okay, I'm filtering the tailing, I'm putting my dry stack in here. Then we found out that the foundation of the ground on which the dry stack is sitting is acting as an aquifer. So there are streams which are recharging, and the phreatic level in the dry stack goes up. So is it a dry stack anymore, even if you have filtered the tailing from the beginning? Maybe not. So sometimes these sort of things can also happen. So yeah, I think it's very important that the accountability always lies on the owner's side. So whoever is the owner's engineer or the representative of the owner, they need to understand very clearly, like they have to manage a lot of things, but technically you have to be competent to interface with your consultants, with the testing houses, and then advise accordingly to your leadership team. And then depending upon, and most of the time in operational side, the decision is made on a risk-based framework. Is the company willing to take or accept certain level of risk in the short term, and then we can perhaps mitigate in a longer term or during the closure of an issue. Sometimes that sort of a decision also may be taken. So I do think a dry stack is the future, but even if we look at reducing what we call as a lean slurry disposal, reducing the volume of water and increasing the solid concentration in the slurry is also advantageous.
Okay. Okay, so hope you enjoyed our panel session. but also still we could not complete that time this GISTM. So again I want to apprise you the situation. If you see that how many, this diagram tells about how many dams, check telling dams in different countries, and that will say how many of them are active, how many of them are inactive, and how many of them are at high risk. So maximum with obviously 291 in Australia, 256 in Canada, Brazil, South Africa, USA, and of India 19. Not that we have 19, because we have reported only 19 is reported in this. Okay, so this is what I say. This is as per the record of Church of England. So these are the different companies. How many tailing dams there? I mean, with the number of tailing dams, Glencore, Rio Tinto, all these things, they are having the maximum. Out of them, how many are active, how many are inactive and high risk. So when these are based on the data, their companies proactively have given the information to Church of England and Reuters consortium. Okay. So, like as I was talking about GSTM, because there was no established no industry standard was there, and Bernardino happened 2019. So then after, actually there was an eye opener for everybody. So even with all these things, when it failed, and I think that was operational, or it was I think it was a closed one.
Yeah, it was closed.
Closed. That means, you see, it was not that we are dumping on it, it was closed, so still it failed. So that way, so this was the beginning of this 2020, that GISTM, and also this International Council of Mining and ICMM Standard 2025 has also come up now. So they set up a independent committee to formulate this GISTM. So this ICMM is the body which has formed this GISTM. And so this started in August 2020. So it has 6 topics and 15 principles and 17 auditable requirements. So they said that there should be some, I mean, it's a guideline. So this is just a guideline, means based on some principle, and like a guideline they have also 6 chapters. So they fix these 15 principles and 6 chapters. If you will see, these are the 6. First is the affected community, integrated knowledge based, and then design, construction, operation, monitoring, management, governance, emergency response, long-term recovery, and public disclosure and access to information. So these were the points which they thought is of importance. So that becomes the part of this GISTM 2020. So first is, if you go for topic 1, that is your affected communities. So first is the affected community. So you see, the principle was started because that was there when they said zero fertility. So because that was the concern of Church of England when that so many people died out of this catastrophic event, Bernardino. So these respect the right of projected affected people and meaningfully engage them at all phases of TSF life cycle, including closure. That means their views are important, which is there, that is that, and that requirement and principle 2, which when I am talking I am not telling you, because if I go for detail I will let them tell me once at least, so then I will come why I have made it. So this is first principle. If you see, respect the right of project affected people and meaningful engagement at all phases of training life cycle, including closure. Second principle says, develop and maintain an interdisciplinary knowledge base to support safe training management throughout the training facilities, including closure. There they said that geotechnical, environmental, water resources, all sorts of interdisciplinary people, social scientists, economic, and so on, they should be part of this tailing storage facility management. Use all elements of knowledge base, that is, you have to use of social, environmental, economy, technical to inform decision throughout the tailing facility life cycle, including closure. So it is not that only technical, also you have to look at the economy, social aspect of it, because if you have heard about sustainability, they said the three pillars of sustainability are social, economical and environmental. Social, environmental, economical. So that aspect said that technical is not sufficient, those aspects also to be considered. Then develop plans and design criteria for the tailing facility to minimize risk for all phases of life cycle, including closure and post closure. So that also to be considered, that is principle 4. Then, because this is a principle, when they are writing, they are then saying what is the requirement and what is auditable. When I am saying the principle, the requirement is more in each principle. So then principle 5 says develop a robust design that integrates the knowledge base and minimize the risk of failure to people and environment for all phases of tailing facilities. Because like so far for last 3 days we are discussing on the topic which is the latest trend, or in the here I was talking about whether I will go for limited system or all I am going for finite method, numerical method. So that means we have to use the best knowledge available. So you can't say that this is available what's there. So the principle says that you have to use the latest and best knowledge available so far, and that you have to use so that people and the environment are intact and they are not affected. Plan, build and operate the tailing facility to manage risk at all phases of tailing facility life cycle, including closure and post closure. So risk and reliability analysis is also part of these tailing storage facilities. At each phase of tailing storage, where in operation, closure or post closure, you have to take help of those who are doing risk. Like risk and reliability, when I am talking about, think about an insurance company. On what basis they are fixing the premium when they are taking the risk? So that way if think about, so that is what you need to take that person who knows how to calculate the risk. So if you think about in a background, so then how they are fixing the premium when they say this is the last amount. So this is the person, those person also to be involved here. Those who can find out what is the chance risk and what should be its insurance. I mean that coming to that insurance comes later, is not part of it. So design, implement and operate monitoring system to manage risk at all phases of facility. Okay. Then establish policies, systems, accountability to support the safety and integrity of the tailing facilities. Here what I was talking about, that hierarchical system in a engineering, you were talking about engineer of record, which system is not there. And senior, what that called, geotechnical engineer. So who can be thus IRDB? So all these concepts are there in built. That means there should be a layer of from the owner side, from the consultant side, from the executor side, who are responsible for all these things. So that also to be recorded and used for all phases. Like here, that is why I am coming to engineer of record. Because EOR is not there in our country, that professional engineer, at least in Institute of Engineers we have, but many people are not aware about it. But where there it is, without that you cannot practice, you cannot sign anywhere and do it. Like Dr. Mishra, what I was saying, he has already taken certificates, otherwise he cannot be there and cannot manage a tailing. So here I am writing one point, when suppose I am saying appoint and empower an engineer of record. What should be? Engage an engineer firm with expertise and experience in the design and construction of tailing facilities of comparable complexity to provide your service for operating the tailing facility and for closed facility with high, very high and extreme consequence classification that are the active and closure phase. So when I am talking about this EOR, whether the EOR or the DOR is in house or external, they must be competent and have experience appropriate to the consequence classification and complexity of the tailing facilities. So there it comes the geotechnical engineering. So geotechnical engineering is the minimum requirement of this, and at least now what they have, Government of India said, for fly ash auditor said he has to be a geotechnical engineer. So that much at least now it has come that anybody designing or in operation or checking it at least has to be a geotechnical engineer. So establish and implement levels of review as part of strong quality and risk management for all phases of tailing facility, life cycle including closure. Develop an organizational culture that promotes learning, communication and early problem recognition. So it's not that is what now suppose indirectly when you are taking every 3 months, or now even one actually one company, I'll not say, so he has asked me that give us per daily, I mean they have to operate, you have to put somebody and operate daily, which is not possible for our part. That means daily wise you have to give a report that today this is the condition, it is safe. Today this is I visited and this is all safe. So that means they are trying to go in this line. In fact, in future, they will say that record will be available. We have taken help of somebody. And in other part, what I was saying, they are simply recording and telling that today morning the top level of the water is so and so in the asphalt. So these type of things should be there in a culture. They are made to WhatsApp. Somebody is giving take the photograph. They have put something like when you are saying piezometer. Piezometer, automatic piezometer. So at the end of the early morning or at the end of the day, you can take the reading once and it will come to your center office. That is the level of all around. That sometimes some people are working on only during monsoon because they have the problem, so they try to monsoon. But think about a water retaining dam. So you know how these engineers are structured. They are saying every level throughout the downstream of the river also they will say the water we are starting from here at 100 kilometers what the level it is also mentioned. So then that's what you are getting information. This river is going to spread and this the level of the water will be so much. This is a danger level. So that has come to that stable, and now we have to bring same way for these tailing storage facilities. For all sets of things should be communicated and informed. Establish a process for reporting and addressing the concern and implement whistleblower protections. Whenever you feel like it should be immediately allowed, you should not stop them, that don't say it to make it bigger problem. Prepare for emergency response to tailing facility failure if it happens. So then what is the preparedness? And then prepare for long-term recovery in the event of catastrophic failure. If it happens, so then how to, because that is what already they got bankrupted, the companies, due to simple 1 or 2 failures. Public disclosure and provide access to information about the tailing facility to support public accountability. So as you know, they have tried with them, very few responded. Because if you give this, if this information available, then they will say that means you are, like when you are talking about water retaining dam, it is public disclosure. The level of this dam is now 632 feet. It is everybody knows. Newspaper also telling this. And now we are that with a notice with the loudspeaker also in the area will say now we are releasing so much cubic meter cubic of water. That is the public disclosure we are doing for water retaining. So that is the type of information you need to provide. If you want to follow this, when we have followed this GI step. So that is all the principle. So if I say, like, I am not going in detail, I am just touching some of the points because this is a big volume. GI step is a big volume, and so here I have taken one. So what it has to be? You see, we need associate skill set, the fields you need. Geography including climate, one personal with this information. Life cycle including closure, he should know how to do life cycle assessment. Life cycle assessment is that every stage of failure, suppose say, what is its impact on the environment, what's the impact on the economy, what's the impact, all these things somebody has to calculate. Mostly life cycle we are calculating for the environment. The risk emergency management, one personal, you should know this. Tailing facility engineer, geotechnical, hydrotech, civil, mining. So they are tailing facilities, engineer who are to be involved for these TSFs, environmental management, then socio-economic community aspects and water. So this is a skill set. Instead of saying that who are there, they the skill, they should have these skills, those will be involved for these TSFs as per GISTM. And if you see what is the role of where. So if I am saying this GISTM principle, it follows all 15 principles are covered in this way. When I am saying management and governance, 8, 9, 10, 11, 12 principles are covered. And if I say communities, vast communities, and who is doing the life cycle closure, that person, and also these socio-economic community aspects, they will see these community aspects. So they know how to interact and how to know them, how much the environmental or economic aspect, social aspect is getting affected or different, making a constructing, operating or closure or post-closure or failure. Everything they will study. Suppose say integrate knowledge based, that means 2 and 3. So where I need geography also need, then I need life cycle assessment, I need tailing storage facilities, environmental concern, socio-economic group and those knowledge in water. So design construction may, this consists of principle 4, 5, 6, 7. So I need this climate that changes, those who have some idea about climate, life cycle, risk assessment, and all here I need this engineering, because this is the requirement, construction, operation and monitoring of the dam. So I need all in technical part. So telling engineers I need it, and environmental aspect I need principle 4, 5, 6, 7, and socio-economic part in of principle 5 and water in 5 and 6. So after 15 these principles, so what are the skill set required also it is put in, I put it in one table. And management and governance, that is 8, 9, 10, 11, 12. So there you see I need the life cycle, then I need risk management and engineering, technical engineer, environment. So then finally the closure, if I will see this life cycle, risk, tailing engineer, environmental concern and socio-economic aspect. So this is the requirement in the different principle and in different phases, or I'll say as different phases of a tailing, which has been mentioned in the GISTM. Somebody suppose a query, should we do our own standard, Indian standard, or we follow those people of 25 mining owners who has prepared this GISTM? Because GISTM has prepared by some few mining owners, ICMM, they had made a committee and they took this initiative and prepared it. So then we need to have lots of information in Indian context to customize it, because some of the things like when we don't have a concept of EOR, engineer of record, so how to fix the responsibility, and GISTM says everybody almost starts finally to the owner. So this aspect is again because they are not again mandatory. They said it is that if you follow, reward, but there is no punishment for if you don't follow. So with this, what I'll say, I'll just take one or two. So like this is a part of the risk. So risk is as low as reasonable practicable. That should be the approach. So because many a times what is there in, if cost by benefit. So this way if I have got to resources, and this is the diagram, I will not explain these things, I just try to I will go for that approach rather. Just a minute. This one we can go for it. So how to go for and do a tailing facilities lifestyle. So we have got, suppose a material. First I start with the project conception, starting. Then I go for design. So as I go for design, then go for construction, then after construction I am going for operation and closure. Maybe, I mean at the end it will be closure, So this operation closure, maybe as you said, some of the ponds you are finishing and making it closer, then going for the second pond and so on. So this may go side by side as you constructing both the operation and closing it, and the post closure. So now do it first. So first is develop plans for tailing management. Then do, what is that? Implement the tailing management system, check, evaluate the performance, then act, review and develop action plan. So this again go back. Once you make a plan, again plan. So when I say this action plan starts, so again you have to revise, everything revised. Because this is everybody with, they become wiser. Today if you are managing a tailing facilities also, after 2 years you become wiser. This summer you may, this winter you may fail, but this monsoon you may fail, but next monsoon you will be wiser. So that is the idea. The principle should be at each phases, because you see, one is also there material changes. Every time this may change, because once I start it in design stage, when the construction maybe something changes in the material, and in course of operation also some changes. So this aspect you have to keep in mind, a cycle, that plan, do, check, act, again plan. So these check also evaluation, they have given some criteria how to measure it. If you plan to, you say that principle you are going to follow. You say that the local people is the first priority. Then how you will do it? Then who will check it, whether you are doing it or not? So that also they have elaborated. Suppose you say that you have considered the risk aspect. Who did that? They have mentioned. And then how to check it, that is implemented or not. That also they have mentioned in this GIS table. So these aspects has been clearly mentioned. Okay. So these I will not go for. No, another thing I may go like. Okay. So what here I can say, so this is like first you have to see that tracking of evolving safety issues. First we have to find out where are the probable points which needs concern. Then diminish the potential hazard. Develop robust knowledge database. These are different aspects. I mean just we have added some of the points just to take it. Prioritize areas of concern, short term and long term. Regular surveillance and monitoring, which actually today what we are talking about instrumentation and monitoring, we shifted to the next class. Because that time we will talk, because this is very important aspect, as I said. These are man-made materials, and this tailing soil is man-made and have been evaluated for last 100 years. But these tailings are still yet to be understood. And in fact, when this, after Brumadinho, there is a good article in Science, America's best journal, small journal like a paper. So they have said that finally, that yet to be understood the long-term behavior of these tailings. We are doing in the laboratory for 1 hour, 3 hours, 7 days, 15 days. But we don't know what is happening after 3 years, these tailings, because they are not inert material. That's why in general, in geotechnical, we are calling it as a translational material, because they are in transitional material. Transition. Today it is there, in tomorrow it may change, which will never happen in a regular. Today whatever is sand is there, tomorrow also it will be sand. But that does not happen in these tailings. So transitional material is the most dangerous part, and so far whatever the equipment is there, we are not able to measure its long-term effect. What will happen if this is stored after 20 years? Like that's why in the morning I was saying, today we are filling the mines with fly ash. We don't know what will happen after 50 years or 100 years, because there is no scope for that to test it in the different conditions. So that was finally they said it is happening. They have no choice. That means it is yet to be understood, and some of the properties, particularly with time, the aging effect is to be yet to be understood on this. So that is only possible if we, regular surveillance and monitor it. In fact, if some of you remember, there was a Konkan railway. Initially when the Konkan rail was constructed, regularly there was failures. Rock falls and other things happened. Slowly with time, now it has been stabilized only through monitoring and so on. So many a times if we really try to do proper monitoring and surveillance, most of the tailing facilities can be taken care of, because in the morning I said soil is not concrete that immediately will collapse. It will give you sufficient warning. Still if we ignore, then it is going to behave differently. Okay, so this criteria I can so this is different about also this in the different other countries are also with the what should be the scoring pattern. If it is not addressed, minimally addressed, partially addressed, compressible addressed or higher standard. Accordingly you can give them a score and then you can say that which is the best country or best mining industry who are addressing this. Okay. So principles. So these 6 elements I will finish it. Almost these are all covered because this is already okay. If you go for this is there. This is requirement. It is a what is the requirement? Suppose I am talking about principle. There I was not telling principle. Use all element knowledge. Okay, so this is the requirement. Already these are covered. Okay, okay. So this is okay. So this classification system is also mentioned therein, like low, significant. What the dam failure consequence there? Extreme, very high, high, significant, and low, depending upon that potential population at risk, potential loss of life, environment, health, social, cultural, infrastructure and economy. So if potential population risk none, loss of life none, then short-term loss or all these things, minimal effect, disruption, low economic losses, but these two should be nil, zero. Then only we say low. That is fact that risk and reliability people who will do the analysis can only tell what is the chances of this happening, that population at risk or population with risk of loss of life. And this way, actually we can say that one is a risk means there is a chances of fatality, but here it is saying that loss of life. That means there is they are at risk. They have suppose say today, if you stay around Dhanbad, there is a chances of or your potential risk of having lung problem. The dust and other things are there. That is the risk. But when you are talking about what is the probability, suppose at the cave scene, how many persons are expected to die. So that is what these two aspects they have mentioned, and all these aspects have been mentioned therein in this GIS term to think about. This plot design criteria, seismic design criteria, all has been also mentioned that what is the probability, like today morning also we are talking about, Dr. Ponda was talking about this and the probability and so on. Okay. So the key role, engineer of record, what should be the responsibility? Responsible tailing facility engineer, what should be the responsibility? All these responsibility and functions have been mentioned. So you see, suppose engineer of record, responsible for the design basis report, responsible for the design, responsible for the design report, responsible for construction and performance. So when I am talking about requirement 10.4, that means principle number 10 and point number 4. So that is what it is already mentioned. So these responsibility or the key role of suppose accountable executive, independent ITRB. So this is now where that is now going to be framed. So they will review the design, construction, risk assessment, governance system and the risk management matters that can affect the tailing facility, ensuring that required expertise and skill sets are involved. So that also they will see that what the owner is doing, whether they are putting all this personnel, and then there will also the external loading design criteria and measure to reduce risk of failure of existing facilities. This is LRP I was saying, low risk. Review of alternative analysis, design construction, risk assessment. All these things they consist of a very senior engineers and academicians. This is when you are talking about ITRB. So these are based on the documentation. What the documentation should contain. It is so descriptive that GISTM, it is costing in Indian currency more than 2-3 lakhs. Some few volumes may be in lakhs. So that way, so all these informations are there. I mean, description also they have prepared. What is a construction record report consist of? Includes among other items survey data, drawings, field report, quality control and quality assurance report, CD5 report, changes required during construction, drilling, field test data, everything you see construction record report should consist of. Many times this is a big issue that, as I said, I visited, they said in 2011 that dam was constructed, now we don't have any record. So then for the review, what are these role of these reviews? So this is internal review will be include reviews of company process, procedure, guidelines and corporate governance requirements and system. Whereas you are engineer of record, they will engineering firm typically have internal review system of all for all engineering work to manage the accuracy and quality of technical product. So this is the requirement and see it is given and telling facility life cycle. When I am talking about this is already I mean just this one I will and then I will close it. This telling facility life cycle when we are talking about life cycle, there is people say 2 ways, either from cradle to grave. Now also people want to grave to again cradle. That means nothing like a grave also you cannot stop it there. That is closure and post closure. So cradle to grave, all this assessment you have to make it, how it is going to affect the environment, economy, technical requirement, everything it has to be considered when we are talking about a life cycle. So that way, project conception, planning and design, that is starting phase, initial construction, operation and ongoing construction may include progressive reclamation, like if some part of you are already reclaiming or you are raising and so on. Interim closure, care and maintenance. Interim closure means after 20 years again they are going for the second part. Closure, regrading, demolition and reclamation. Post closure, relinquishment, reprocessing, relocation and removal. Like now at this point I will say now most of that fly ash pond particularly we are saying the legacy ash we are going to utilize it. That's why now all the firms the target is that more than 100% should be utilized. That means part of the legacy has to be utilized. But the problem with this, what they are facing, like it is not that excavator one is how close it can go and how much from where it can excavate and send it. Another problem is also having a dust problem. Some of the companies also contacted, like, have you got any method? I said the chemical only spray, because when they are operating it, so during that time also, that means it is closed now, what they are working, it is, they want to rehabilitate. That means so that they will get land and it can do anything. But that time we get problem with the dust. While they are excavating and loading, lots of dust is coming. I mean those who are dealing with, I mean they are sprinkling or mostly managing with it. And the chemicals which are being used, some of them are, the chemicals what I said, obviously you have to sprinkle it. Many countries have got that. Like here we have got these mines. In African countries, on the road they have got this problem. Because the dust is a major problem in the African countries, dry. So they are, I mean sometimes also the deserts travels into the land due to wind. So they have to, I mean suppose we are rivers and seas are getting into us, but for them the desert is entering to that continent. Because sand blow हो गया फिर आधा किलोमीटर चढ़ गया, फिर next after 2 years another blow है, another become desert, because desert is in size. So this dust problem is there, so we have to look at the other aspect and how they are managing. So dust problem, mostly sprinkling of water is not at all a suitable proposition. How much water we can spend, after few hours it will dry up and go. So best option is to go with the chemicals. I mean that chemical also should be only we check. Suppose some chemicals came to our laboratory, it should not be hazardous. It should not contain any hazardous material. That first you have to check it and get certified. So that the chemicals what they are using, because it will go finally to the groundwater. When you are sprinkling in the air or while you are spreading, it will go to the groundwater. So that you have to, and so that now people are using some of the biopolymers and other which are non-hazardous for this case. So I will not take more time, it is already now around 6, so I stop it here. If you have some doubt or so, I can answer one or two.
Only one question, sir.
Yes, please.
This GISTM keeps on updating how many years, like, or it is a guidelines which is fixed for, like, just, it is getting updated?
2020 there, 2025 they have made some changes. 25 is a different document. From Dr. Panda.
Sir, Ji,
2020 this GISTM first came up.
in 2020,
2020 it came up.
recently, it's not.
Yeah, this is recent.
Yeah.
So what they did, they make it like a voluntary.
Sorry?
They request the mining companies who are voluntarily trying to make all their site compatible. So voluntarily who cannot, but then they give that 2025 deadline. 2025 deadline is who voluntarily said we will do that.
We will contribute to it.
Exactly. But in 2025 also, that what I was mentioning, the rating system. The rating system is coming and also more guideline is coming who will be doing that. Like they are saying, it will be your, and there will be a ITRP, and there will be a dam safety review, and also the GISTM compliance, who will be doing that. So those kind of ratings are also coming in 2025. So that will give much better guideline to everybody. That the people who are involved, they are the competent people.
So, sir, in designing, only these guidelines we have to follow. Otherwise, so whatever analysis part is there, like in GISTM, nothing is mentioned about what
Nothing
type
is
of analysis or what
correct.
type of
Nothing is
approach you have to.
That's correct. Nothing is mentioned, so far nothing is mentioned. Recently that IIMSMC, they have come up. I will come up tomorrow, maybe I can show you something there.
Okay.
Yeah.
Because it is just a
Guidelines. to
holistic
follow.
use of the information and knowledge.
Yeah.
When we
Design
know
part,
that,
it will not be useful. Like what we design, we use Indian standard codes, like some formulas, some.
no,
method.
what it is saying that in the design you involve the competent person.
That's it. It's saying.
And in any implementation, you use the competent person. That it is only saying.
Yeah. Got
It is not saying that technically what method you follow, but you have to see that the competent persons are used. And something like review, who should do the review?
Yeah.
And when you are talking about water, what should be the water floor level or what should be the earthquake? All these informations are only there. How many years you should consider as the period for which your tailing storage facility should be designed. So that aspects.
General guidelines.
Yes. And that is one mentioned, that the latest tool you have to use, no, knowledge. That's the knowledge you have to use.
Yeah.
Best knowledge available.
Correct.
Sir, like the several reference you have shown yesterday, like encode code is there, iCode code is there, and the GST guideline is also there. Is there any difference between this country-wise code and this GSTM between conceptual basis?
Yes, I see you have got, you are belongs to which branch of engineering?
Geotechnical engineering.
Geotechnical civil engineering. Civil engineering, we have got Indian as called IS code. American Society of Testing Materials, ASTM code. We have got also IRC code.
Yes.
So it is just like that. Somebody, one from Canada, one from Australia, and the GISTM is an internal association where they have not, technical is not there. Mostly they have given some guidelines to follow a protocol. And in the standard means that is it's a guideline. It is not a binding or whatever, it's a guidelines. So that is the difference. Uncalled, iCalled, uncalled, iCalled also now India trying to do this one. they are organizing also some of these things, because mostly it is so far was related to small and medium dams dams. So there it was not mentioned that it is a tailing dam or any dam. But in their Canadian Australian style they mention it for tailing dam.
So sir, I called
So
in.
these country-wise codes are much more clarity they are giving.
Localized, customized. In Indian you see, Indian we know what is best for us. Like now you have got, suppose any other matter, now we have got ISO standard. So should we follow ISO standard or Indian standard? Because this standard game is a big business, not business, actually it's a big forum, and where as a country we are failing. Some other forum, because I am part of this BIS, I know that a small thing, if you don't do it of your own standard, you are going to fail to implement, use, sell your own product. So that's always it's better to have your own standard.
So I called are sir, what international guidelines or it's code? Like what is that? Code. I called is code.
Open this.
I don't know about it. That's why I'm asking.
No,
Yes, Dr. Panda can attest.
it's not code. Like I will, maybe tomorrow I will show you something. Like,
Because I heard only these terms. I am not aware about it. That's why I'm asking.
it's a large dam. I call it the large dam. So recently, the tailings considered as a large dam. So tailings went into there. Like again, everybody in worldwide, there is a movement. Like we can see that in each site, we say we do not have inbuilt design. We do not have that. We have a design also, we may not have that. Is there a design report? We may not have that. Like so many things we are ignoring. So that's why they, instead of focusing the technical side, because they know the technically people are doing good. Like I think he mentioned, we technically we give a good design. But when contractor go and do it, it doesn't do good. But that's why they are keeping the owner responsible. So owner should have that. That's why they are implementing like every 3 years, you should have a dam safety review. Every 5 years, you should have a ITRB board that review it. Every year, you have an internal team to review it. This is called annual performance review. So all these reports should be there. Right now, if you see, we do not have anything. So definitely, it may take time, but maybe 5 years or 10 years. If we have all these things, it will definitely improve. So that's the goal.
That means that is GISTM specifically for these and the unfold obviously for the water storage. It was the initial for water storage. Yes, any other thing? Okay, thank you. Stop it here. Tomorrow one class will.